So I just started recording. So what you're doing in this, so like as you can see, you have the building circuit, simple circuits lab sheet. This claim is what you're going to do. You're going to answer that question before you actually start working on the lab. So you're like, how does the arrangement of resistors in a circuit affect the current that flows through the circuit? You're going to take a guess. After you do the lab, you might adjust your idea. So what's going to happen is we are going to work on the lab, which is right here. So what you're going to be doing, so there's two forms in which we're making um, our circuit. So we have, you're going to be doing in parallel and in series. So what you're going to do is, first things first, you want to make sure all of your resistors are the same, and same with all of your batteries. So what you're going to do is, when you go to your thing, you're going to click on your battery. You see the 9 volts. Now you're going to go back to your other sheet, and where it says battery voltage, you're going to put in 9 volts. You can choose whatever voltage you want. Just make sure it's the right voltage for the circuit, and then you're going to do the same thing for your resistor. So you click on your resistor. Oh, it's 10 ohms. You want to make sure every one of your resistors is 10 ohms. That's sort of the base value it gives on each one. So then you go back to your document and you put in 10 ohms.
Ronan. Using this? Shit.
So that's what's going on there. And then what you're going to do is you'll need to grab the ammeter and sort of have it be part of the circuit. So what you'll do is you'll connect wires. So we're going to start off with doing series, so we make it like a snake. And then we connect it here. And then last but not least, we connect it there. So we have two resistors, and we have a current of 0.3 amps. So if we go back to our sheet, over here we have them in series. So what we'd do is we'd put the 0.3 amps over here. And then what we do is we do some calculations to figure out our voltage. So we can do the calculations. Oh, why is that not doing it right? One second. Okay, so what we're going to do is, if we look at our sort of building simple circuits, we have the 0.3 amps. So what we'll do is we use our equation. R
There, I cut it in
equals V over I. So we're trying to find the effective resistance of our circuit. So what we'll do is R equals, our voltage is going to always be the same because we're just using one battery, so 9.0 divided by 0.3. Oh, whoops, I have the wrong thing.
Viewing. Is it called Lab CER?
And so we do the division. Yes, it's called Lab CER. We do the division, and so then we end up with about 9 divided by 0.3 goes in 3 times. We end up with about 30 ohms. So R equals 30.
Okay.
And so we'll go back to our thing. And we'll put in 30 ohms. And then we're going to sort of do the same thing. So now we go back to our circuit. And what we'll do is now we'll turn it into a parallel, so we can well, actually we can leave it like that. What we can just do is go bam. And bam.
Talking to friend.
Although we can delete this one. So now we have a current So now we made it like a ladder. So it's like rungs of a ladder, and so now we have a current of 0.6. So we'll go back to our thing. We'll put in the 0.6 here. Amps, and then basically do our math again, and we end up with 15 ohms.
Dan,
Yes.
while I was trying to follow your steps, I kind of accidentally lit the battery on fire in the simulator.
That means you're probably shorting the battery. That
Yeah,
happens. You can always click on a connector and just snip the connector and just redo.
how do you
some of
snip the connector?
So you click on where their connection joint is, and then you click the scissors to cut it.
Oh, okay, there's like scissors that you can use.
Yeah.
Okay,
And then it just cuts the connection, and then you can redo it. So, what's going to happen is, so now that we have it for our when we use 2 resistors, now you're going to do it where you have 3 resistors. So we can just sort of cut this, and then we can just add another resistor. Although, 1 second. Boop, boop. Now they're like a snake. Snaky snake. And now we have 0.22 amps. Let's just turn off resistance on our... Well, actually, what if we increase our resistance? No, we'll just leave it at the standard 10.
Vinny, stop it. Sorry.
So, basically, you have this, and now you have a new current, and then you'll figure out the effective resistance of the circuit. And you'll sort of keep doing that until you end up filling out the table. And then you'll sort of come to a conclusion and explain, like, well, how does the arrangement of resistors affect the current?
Stop meowing.
And so you'll answer that question, and you'll use data from your table to support that. I encourage you all to actually do a version where you just have 1 resistor, which this would be an NA, to sort of give you a baseline.
That was interesting.
To sort of do all that. So, are there any questions?
Wow.
Any questions before I stop recording and put this up on YouTube?
No, probably.
Wait, this will be on YouTube? Yay.
Yeah.
Here's a question. What does
Well, this is
frequencia mean?
What?
That is the question.
Spanish.
This is not Spanish, this is physics, Savannah.
It is now.
I'm just
Oh,
standing
it's
here just
frequently.
from
Alright. I'm stopping the recording.